Okay, so we start. So we were talking about MDPs and right. So just to recap, what is a policy?
We are moving from state 1 to state 2 by an action. So
How many of you know what is a policy? Okay. How many of you think that they know policy? मतलब जिनको पता है उनको तो पता ही, उनके अलावा? Okay. So we still don't have the whole class saying they know policy. We were here somewhere. Yes. What is a policy? Policy is you tell me in every state what action should I take. Right? If it maximizes your expected utility, then it is optimal policy. Right? So a policy does not have to be optimal per se. Why do we care so much about policies? Why do we care so much about policies? So let's say if this grid world is given to us, ये जो अपना जो example चल रहा है, running example, this one, if we talk about this grid world, right? Why do I care about policies? Why do we care about policies? अच्छा, कितने लोगों को पॉलिसी बिल्कुल नहीं समझ में आई है? रेज योर हैंड्स. मोर पीपल. ओके. पॉलिसी इज सिंपली जस्ट दिस. इन एवरी स्टेट टेल मी व्हाट एक्शन शुड आई टेक. ओके, दैट्स इट. Caveat here is in every state. Right? So if I give you an action just in one state, is that a policy? No. Policy means for every state you know which action to take. Now if for every state you know what is the optimal action that will maximize your expected utility, in that case you will call that policy as optimal policy. That is it. Okay. Why do we care so much about policies? This is what we require in the end. So once a problem is given to us, right, what we care about in the end is, give me the policies. Basically for every state what action should I take, and if that action is optimal, then this is what I am looking for. Okay. So what was this thing? What was noise plus 2? I mean 0.2? That probability of not going in the direction you intended to. Discount 0.9 means? Right. So if you take reward later compared to right now, which one is preferable? Right now. So the earlier the better. Living reward is 0. What is this now? In which case did we have this living reward? When we were talking about optimal policies there, living reward was minus 0.01, minus 0.03, 0.4 and minus 2. Okay. So those are living rewards. They are 0 now. Why don't we need them? Sorry? No, my question is, why don't we need this anymore?
Number of steps will not decide.
Right, so that's a question for you. Why don't we need this anymore? Why is this equal to 0 and still fine?
because we have introduced discount.
Yes, but let's continue with this. What are these numbers? some numbers. Okay, what is this plus 1 and minus 1? You are here, what do? You take exit and reward is plus 1. If you are here, exit with minus 1. Everywhere else, so why are they all less than 1?
Because they're not equal.
Because one is the end point, that is the goal, we need one, and they are the intermediate rewards.
Right, so there is no living reward, right? That means if you go from here to here, it costs you 0. You are not going to get any reward if you go from here to here. The only places you are getting reward are these 2 points. Okay,
So what are these numbers?
what are these numbers? That's my question. Huh. Probability. Okay, अब no, so if I make it 10 and if I make it minus 10, do you think this will have impact on these numbers? No? Alright, no. What do others think? देखो, all these things are worth discussing because I don't think reinforcement learning पे इसके बाद में कोई कोर्स करोगे unless you go to either IITs or to US for your MS. हाँ. If I change this to 10 and minus 10, will these numbers change? How many if you go for yes? I'm not asking why, but how many if you go for yes? How many if you think they won't change? Why so? For you guys, why so?
Because they are just a directional probability, and that is the reward. That won't change the way in which action can be taken. Probability remains the same regardless the point reward.
Okay, so why is the probability of moving left from this side is so low, 0.28? I mean, here it should have been higher, right? This way I certainly don't want to go. If I end up going there, that's a different thing. I should move with probability 1 on this side, or correct me if I'm not. No. My decision will be deterministic to go this side. My action takes me here or not, that has a probability. Right? So these numbers are not probabilities. Right? Everybody sitting here, these numbers are not probabilities. Just because they are all lesser than 1 and you have 1 sitting here, they are not probabilities.
Can we say that numbers are utilities?
Can we say?
These numbers are utilities?
These, yes, these number are utilities, because what are you trying? What are these numbers? What are these numbers? These are Q state values. Okay, these are Q values जो अपन ने previously देखा. They are leptoplates down. Okay, so what was this? these are V values, these are Q values. Okay, how do you compute them? Okay, I'm very far from yet explaining ki bhai what are they, so I'm yet to explain that, right? I just want you guys to know this. So there is this V star. What is V? Some values. How do you compute? We'll come to that. What is Q star? See, star lagate hi means you are talking about optimal. So V, Q and pi. Pi we know is policy. What is V? Some number. Okay. Expected utility starting in S and acting optimally. Why is this term acting optimally here? Because it is V star. It is the optimal utility that you can get from where? From this state S. See, we don't talk about optimality, you know. We are talking about optimality starting from a state S. So, if I start from here, I will have a, so what is this 0.57? Values after 100 iterations. So this is my V star at this place. V or V star, but this is my value here. So if I start from here, I need to go here. This is the maximum I can get. Okay. So these are those numbers. What are these numbers? Here. Why you have 4 for every state? Because in every state you can take 4 actions. Now if you see, the value utility of a Q state is, it just doesn't depend only on the state but also on the actions that you can take in that state. Why only one value is here? For every state there is one value. Why 4 values here? For every Q state you have 4 actions. Okay, is the difference between these two figures clear? देखो इसमें बहुत super confusion रहता है. That's why I am just taking a lot of time here. These are which values? Q values. But can you find out sums? Can you give me the first figure from this figure? एक बार देख लो ढंग से इसको. Look at these numbers. So let's say look at this is 0.64. 0.64. Okay. 0.74. 0.74. यहाँ पे 0.85 था. So अब बताओ इस स्टेट में what will be the value? Okay. In this case 0.49, 0.43, 0.28, 0.48, 0.57. Okay. Where are these numbers coming from? That's the biggest question right now. So fundamental operations compute expected max value of a state, expected utility under optimal action, average sum of discounted rewards. This is just what expected max computed. We have the most important equations for reinforcement learning. These are called Bellman equations. I mean, we'll formalize them more. No, this is what it is. V star S equal to max of Q star SA. What is this? ये equations रट लो. I ask a lot of questions on this. What is V star X equal to max of Q star SA? What I just said before, right? That you can obtain this figure, these values from these values. Done? Next, what is this? So now, see, I can compute V star from Q star, but how do I compute Q star? What is this whole thing? what is the last equation doing? So you just put the value of Q star from here. So that is of not importance to us. R क्या है? I don't know. Reward. So what does S comma A comma S prime mean? Reward when you go from state S, take action A and end up in S prime. So that is the reward. What about this guy? Same thing, same story. When you are in state S, take action A and end up in S prime. What is this guy? Okay, so before that, this is your, what is this? You have to help me understand this. I don't understand this. दो मिनट, I mean, stare at it for few seconds. I don't understand what does this mean. मैं कह रहा हूं इसको देखो एक बार. Right? What is it? See, what is RS? What is R? Reward when you go from S to S prime. What is this term? एक बार गामा हटाओ. So which kind of equation is this? Do you see some recursion? See, you are writing value at S. You are writing value at S in terms of value at S prime. Which one is closer to a terminal state? So which one will help? So which value will I get first? Vs or V star? I mean V star S or V star S prime? Right? So I can compute V star S in terms of V star S prime. I'll get rid of this equation again because जबरदस्ती तीन equation दिख रही है अपने को जबकि actual में दो ही हैं. Why is gamma here? Why do you have gamma here? आज की क्लास में ये दो इक्वेशंस मेरे को समझा दो एंड आई एम डन. I am just looking for these two equations. This is straightforward. What about this one?
These are S prime is recorded at S prime. And so it is found that because that came later from the S state.
That came?
Later from the S state. Because first we are on the S.
Right. So now anyone else? Can you repeat it once more?
Currently we are on state S. We take it short as R S A S prime.
Right.
And then add V star S prime with the discounted value.
Right. And why do we do so?
So that is a later reward.
What is gamma? How many of you know what is gamma? What does it do? How many of you don't know what is gamma? Everybody knows? Nice. You are writing value of V star S, as we'll see in this, in terms of V star S prime. S prime is how far from S? One step away. So you have just gamma. Let's say if I want to write it in terms of some state that is two steps ahead, that will be gamma square. So why do we have gamma here? Because V star S prime is the value in the next state. It will take me one step to reach there. So the moment I take one step, I have to multiply the value there with gamma. What is this guy? So if you look at this, I go from here to here. This is my R plus whatever is value here. But this value has to be multiplied with gamma. Is this part fine? All it is saying, you start from S, you take one step here, तो वो जो भी utility है, that is in terms of R here. Now, V star S I can recursively write just by multiplying gamma with it. If you have any questions here, ask as many times as you want. These equations are going to stay with us until the end of the course now. I don't know. Anybody to help me here? Why are we adding this to R? What are R's? They are utilities, right? So those are the only numbers we are keeping track of. So even V star S, that is a form of. So what is V star S prime? So I want it exact statement. V star S prime. What is V star S prime? If you start from S prime, then what is V star S prime? The maximum expected utility that you can get if you start from S prime. Why have we multiplied it with gamma? Because this is happening at the next step. Why add R? Because reward to reach from S to S prime has to be added. Questions? Yes.
Sir, V star S equal to max Q star S.
एक सेकेंड,
Q होना चाहिए ना, Q star
यहाँ पे
we are finding optimal Q from this, that becomes V star, right? We are like 4Q
हाँ.
previous
Right.
that box. Then we are taking optimal from it, that becomes V star. So why max Q star? It should be only max Q.
Yes, say that now.
Q star max Q होना चाहिए sir. First.
This one? Folks, I have this कि भाई Q star क्यों है यहाँ पे? Let's go back to these definitions. देखो, if you don't let me move out of this particular equation, I'm fine. But इसको जितने लोग हो सके उतने लोग समझ लो इसको. What is V star? Expected utility starting in S and acting optimally. Q star? Expected utility starting out having taken action A from state S and thereafter acting optimally. What was the construct why do we have this Q state here?
Because after this environment decides chemically.
See, here who decides what to do? Here agent is deciding what to do. So agent decides I go north. Will agent always go north in our setup? No. But that thing is beyond the control of agent. So agent has taken north here. But agent may or may not go to north. So it can go to any of these 4 states here. Actually 3 in our case. Right? The probability of going backwards was 0. But still you have 4 cases nonetheless. Now you come here. Okay? Is this some real state? This is not a real state. Right? This is just a mathematical construct. No agent is reaching this state per se. Agent takes an action here and reaches here. But this construct is mathematically very helpful for us. Right? So we keep it. What is this construct? Agent has played its move. Environment is to decide which state does it go. We are keeping it separate from agent because agent has no control over environment. Agent has taken its action, whatever it was. So when you are in state S, take action A, right? You end up in this Q state. Now from here you can go to any of those S prime. If you go here, the S prime here, what will be those equations? Same, because we are calling that S prime only. Questions, more questions here. What is V star S? What is Q star SA? Basically all these terms that are in these equations, that are in these two equations should be clear to you. You should know how do we get this one, and then what I don't understand is what is this term.
You do this with extra transition mora to use reward or discount.
Right, so what is this summation over then?
We take average because that transition function is probability.
Right. So when you are here with probability 1, you will go to S prime. That S prime can be this, that S prime can be this. One of these S primes. How many total candidates for S prime for our case? 4. But the probability of going backward was 0. So let's say this, left, right, north. What is this guy giving me? The probability that I go to a particular S prime from S. But there are many S primes possible. So you take this number. What is this whole quantity now? Weighted average. Okay. In our case, what is the probability of north? 0.8. So 0.8 times this plus 0.1 times for left S prime plus 0.1 times for right S prime plus 0 times backward. More questions here. Acha, if I have instead of 4 squares, let's say, you know, I have a grid of something, let's say this kind. Let's say 6. So just forgive this drawing. Okay, from here let's say you can go to 6 states. How will this equation look like here? Give me the fully expanded form, because it will still look like this, exactly this. But how many terms in summation will it have? And from here, if I have P1, P2, P3, P4, P5, P6, what will be summation Pi is? 1. Okay. So these are those probabilities. This is your S. Any of these guys could be S prime. So I can go from S to, let's say, probability of going to any of these S prime is 1 by 6. Equal probability for all of them. In that case, if I want you to write this particular equation in terms of values, how will you write it? I mean, inki values chodo. 1 by 6 times R from here to here. 1 by 6 times R from here to here, and so on. बोर हो गए इस इक्वेशन से, तो आगे चलें. चलो, बट स्टिल यू कैन आस्क क्वेश्चंस. We will come to that. So, okay, let's not start a new example. Right. So, what was the question? हाँ. So, एक सेकेंड देखो, somewhere they will give you, हाँ, So let's say we start from here. एक बार इसको छोड़ो, car racing, we start from here. Why do we have zeros? Okay, so initially you get to know that these are which values? Why this 1 and minus 1? Why not here somewhere? So these are my terminal states, right? And terminal states pe values are known. So we define values here first, 1 and minus 1. Now what do we do next? First iteration. Okay, how come 0.72? And then we'll see values after 100. What is going on in here? I think this is the right point to stop. Ponder over these numbers. Where are they coming from? Starting from here. So starting from here, this one, because they are terminal values. How is this number coming from? Figure it out. And second question, which this I am going to take anyway in the next class. Why are these numbers changing? Why is this 0 here? How many?
How much time stamps are left before the game ends? So like here 3 time stamps are left. So you have only 3 steps.
Right. So my question here is, I am here. Okay. Why do I get value of this state first? What happens in these kind of trees? You start from bottom up. Okay. Which state is the farthest? This one. So you will get values here in the end, because things propagate from the bottom. Okay. Now let me see if they have q values here somewhere. Okay. So but we have q values anyway before it. So try to figure out these numbers. Just one. Your homework is just for this one number, 0.72. Okay, we are done for today. Attendance, 1 second. चलो डन.
इसमें ये वाला तो रिवॉर्ड है. ये क्या है, मतलब ये
This reward is when you go from S to S prime.
तो जो एंड में 1 था, एंड
कौन
में
सा?
जो 1 आया था, मतलब जो हमारी टर्मिनेटेड 1 है, ये वो वाला रिवॉर्ड है.
I won't speak right now. ये तो होमवर्क दे रखा है मैंने. Reward is when you are going from S to S prime.
So that is 1. वो तो ठीक है, चलो 1 हो गया. Then why are we not multiplying gamma with this?
Why are we not multiplying?
This with this.
R S A S prime तो मैंने इस स्टेप पे लिया. That comes as it is. लेकिन V स्टार S प्राइम यहां से वैल्यू मिलेगी नेक्स्ट टाइम स्टेप से. So there I have a gamma city.
बट फिर ये तो अपनी करंट स्टेट पे हुआ ना, ये वन वाली जो मेरी टर्मिनल स्टेट है उस पे थोड़ी लग रहा है ये गामा।
कौन सा?
गामा मेरी जो टर्मिनल स्टेट है
हाँ।
उस पे थोड़ी लग रहा है, उस पे लगना चाहिए ना गामा तो, जो टर्मिनल स्टेट है।
देखो जाके। बताओ।
चालू है क्यों?
नहीं पता मेरे को, मैं सीधा इधर आया हूँ।
मेरे को जाके आने
जब जाके आ ही रहे हो ना तो मेरी वाटर बॉटल भी उठा लाना। तुरंत आ रहे हो ना? हाँ। आई हैव अ क्लास, तो 10 जल्दी खा लो, है ना? आराम से खा लो जब तक। मेरी क्लास में भी खा सकते हो आराम से बैठ के, बट जस्ट रेगुलरली नहीं, कि मतलब यहीं पे आके आ जाओ। हाँ। Okay, recording is still on.